This is quiz 24, and on this problem you're supposed to find where f is increasing, decreasing, where it's concave up, where it's concave down. For the function f of x equals a polynomial 4x cubed plus 3x squared minus 6x plus 1. Okay, so that information is going to be given to us by the first and the second derivative. So let's just go ahead and calculate both of those. First derivative, of course, is 12x squared plus 6x minus 6. And the second derivative is going to be 24x plus 6. Now I like to start with the second derivative, which gives us the concavity, the shape of the curve, because it's usually easy to analyze. So we factor out a 6 from here, so it's 6 times 4x plus 1. So the whole story of the second derivative is told by this. 6 is positive, so I can ignore that. It's this guy that's going to tell me where we get positive, where we get negative. So when 4x plus 1 is positive, we're going to have a concave up curve because the second derivative is positive there. So that means 4x is greater than negative 1, x greater than negative 1/4. So we have for x greater than negative 1/4 concave up for our function. And obviously then for x less than negative 1/4, that'll make this quantity negative. So we get concave down. And so that's going to make negative 1/4 a point of inflection because the concavity changes around negative 1/4. To the right of negative 1/4 we have concave up, and to the left we have concave down. So I can already tell pretty much what this curve is going to look like. No surprise. On wherever negative 1/4 is, we're going to have a concave up curve from here and a concave down curve from there. So it's gonna be your typical cubic polynomial, which is not drawn real great here, but that's the basic shape, and you know it's going to look like that because if it's 4x cubed, it's the leading term, so it's going to have to go up this way and down that way. But we now know that x equal to negative 1/4 is this point of inflection. Okay, so next let's look at the derivative. Again, factor out as much constant as you can. So it looks like 6 can come out pretty easily, leaving us with 2x squared plus x minus 1. Okay, now we need to know where is this positive and where is it negative. Again, 6 is just going to sit there. It's not going to matter too much. So the story is told by this term as far as where it's positive and where it's negative. It's usually a good idea to try to factor this thing, figure out where the zeros are. So let's do a quick check. Is it going to be difficult? What is b squared minus 4ac in this problem? A is 2. Let's just write this down. For the quadratic formula, a is 2, b is 1, c is negative 1. So b squared minus 4ac turns out to be 1 minus 4 times 2 times negative 1. 4 times 2 is 8, minus 8, minus 8 is plus 8, that's 9. So b squared minus 4ac is 9, square root of 9 is 3, so this is going to come out as a rational number, a whole number. And so that means that it's going to factor, so I don't like wasting time factoring if it's not going to factor. So I check out the discriminant here to make sure that it comes out to be a perfect square, and then I'll go ahead and think about factoring this thing. So the derivative is what we're looking at. The derivative is 6 times something, and the something is these two terms that have to multiply together to give you 2x squared plus x minus 1. So it looks like I'm going to have 2x and x for sure, and the only numbers that can multiply together to give me 1 are 1 and 1. Now we have to worry about which one's plus and which one's minus. So let's just try 2x squared. If I put plus, well, let's do it the easy way. What if I put minus there? then this is going to give me minus 2x and plus x. Minus 2x and plus x is wrong. So this is what it's going to be, plus and minus. Okay, let's just check that out. 2x squared plus 2x minus x is plus x. That's what I've got. And then minus 1 times 1 is minus 1. So this is how it factors. So this is the derivative, and the derivative will be equal to 0. So the derivative equals 0 when x equals 1/2 or x equals -1. Now that's not really what I'm interested in. Those are the points where the derivative is going to be 0, but it's also going to be the places where the derivative changes sign. So you think about it this way. You plug in, you think about -1, and you think about 1/2. These are the places where the derivative is equal to 0. So the derivative is only 0 at those two places, and the derivative is a fine continuous function. So it's going to go positive, negative, positive, or negative, positive, negative, and all I need to do is test a couple of points. Let's just plug in 0, for example, and when you plug in 0, which is right around there, you're going to get a y value of what? 0 minus 1 is negative, 0 plus 1 is positive, so the whole thing's going to be negative. So I have a negative answer down here. It's got to stay negative in the interval from -1 to 0, because these are the only roots for the derivative. And I'll bet you that if you plug in a very large negative number, like -100, this guy's going to be negative, this guy's going to be negative, the result is positive. So yeah, the derivative is going to be positive in here, negative in here. Same thing for a large positive number as a test number. 100 makes this positive, 100 makes this positive. So yeah, it's positive here. So from that, we can tell that the derivative is positive when x is out here or x is back here, and negative when x is in between -1 and 2. So the derivative is negative here, so that says that f is decreasing on the interval from -1 to 1/2, because the derivative is negative in between those two roots. Just plugging in one number will tell. And any number in between here, you can see that that's going to happen. Because for any number between -1 and 1/2, this is still going to be positive, but this guy will be negative. Okay, so f is decreasing there and increasing outside of there. So let's just write that down. That says f is increasing when x is greater than 1/2 or x is less than -1. And that is it. I suppose, sometimes they ask you to use interval notation. So increasing on the interval from 1/2 to infinity, or less than -1, so minus infinity to -1, like that, and decreasing on that interval. Okay, and we've already got the concavity taken care of. So that's it for that particular problem, and that's really it for quiz number 24.